We'll be there. Wink and a smile and a great old time. You will be there.
For our performance tasks in robotics, our group worked on different projects using the Arduino board. We explored how to control lights, buzzers, and 7-segment displays, and even modified some of the codes to make the outputs work the way we wanted.
Throughout the process, we learned how each component functions and how coding plays a big part in making everything run smoothly.
It wasn't always easy, but we enjoyed experimenting, troubleshooting, and seeing our ideas come to life through Arduino.
LED in Arduino is a small light that shines when electricity goes through it. It is often used to show if a program is running, if a signal is sent, or if something is working. In Arduino projects, LEDs are used for simple tasks like blinking lights, showing power, or making light patterns.
A blinking LED in Arduino is one of the simplest projects that shows how to control output using code. The LED turns on and off repeatedly with a short delay between each state. This happens because the Arduino sends a high signal to turn the LED on and a low signal to turn it off. By changing the delay time in the code, you can make the LED blink faster or slower. A fading LED in Arduino is a project where LED slowly brightens and dims instead of just turning on and off. This effect is made using analog output, which controls how much power goes to the LED. By gradually increasing and decreasing the signal, the LED appears to fade in and out smoothly. An alternating blinking LED project in Arduino uses two LEDs to turn on and off one after the other. While one LED is on, the other is off, and then they switch. This is done using simple code that sets one LED pin high and the other low, then swaps them after a short delay. It's a basic way to learn timing and control of multiple outputs in Arduino. A button-controlled LED in Arduino is a project where the LED turns on or off when you press a button. The button sends an input signal to the Arduino and the code checks whether it's pressed or not. If the button is pressed, the Arduino sends a high signal to the LED pin to turn it on. If not, it sends a low signal to turn it off. This teaches us how to use digital input and output together. In Arduino, a potentiometer controls LED brightness by sending a variable voltage to an analog pin. The Arduino reads this value and adjusts the PWM signal on the LED pin, making the LED dim or brighten smoothly.
Throughout our robotics performance tasks, our group faced a lot of challenges along the way. Each lesson taught us something new, not just about Arduino, but also about teamwork and communication. In the light lesson, our main struggles were miscommunication and technical issues. Sometimes we got confused about who should do what or the board would work properly. There were also moments when the light bulbs or wires are broke, which slows us down even though there were times we joke around and disagree. But we managed to fix things by talking properly and working together until everything worked.
Buzzer in an Arduino is a small electronic part that makes sound when it gets electricity. It can beep, buzz, or play simple tones. In Arduino projects, a buzzer is often used for alarms, timers, alerts, or to give sound signals when something happens in the program. A buzzer beep on button press in Arduino is a project where the buzzer makes a sound only when the button is pressed. The button acts as an input and the buzzer acts as an output. When the Arduino detects that the button is pressed, it sends a high signal to the buzzer, making it beep. When the button is released, the signal turns low and the buzzer stops. This shows how to control sound using a simple input signal. An SOS Morse code with a buzzer in Arduino is a project where the buzzer beeps the SOS signal automatically. The Arduino controls how long the buzzer stays on and off to form short beeps for dots and long beeps for dashes. This pattern repeats to represent SOS, a common emergency signal in Morse code. It teaches how to use timing and loops to create sound pattern with a buzzer. A light-sensitive buzzer alarm in Arduino uses light sensor to detect light levels and control a buzzer. When the light gets too low or too high, the Arduino sends a signal to turn the buzzer on, creating an alarm sound. When the light level goes back to normal, the buzzer turns off. This project shows how Arduino can use sensor input to trigger an automatic sound alert. A buzzer sound controlled by potentiometer lets you change the pitch of the buzzer by turning the knob. The potentiometer sends a signal to the Arduino, which adjusts the buzzer's tone based on that input.
For the buzzer, we went through almost the same problems: broken jumper wires, miscommunication, and small mistakes in wiring. One of our group mates also missed a session because of untraining. Even so, he managed to excuse himself and rejoin the following meeting. We appreciate that he still found the time to join us, and it reminds us how important teamwork and understanding are.
7-segment display in Arduino is an electric display made out of 7 LED bars arranged in a number shape. It lights up in different patterns to show numbers 0 to 9 or some letters. In Arduino projects, it is used to display values like time, scores, or sensor readings.
Displaying a single digit on a 7-segment display means lighting up specific segments to show one number like 5. The Arduino sends signals to the right pins to form that digit. Makes the 7-segment display show each number in order. The Arduino changes the segment signals one by one with a short delay between each number.
The 7-segment display lesson. The hardest part was making the segments appear correctly. Sometimes the issue came from the wires, and sometimes it was the display itself. It took a lot of time and testing and adjusting before we finally made it work. It was a bit tiring, but also satisfying once we saw the results.
Wherever we are, there's a fun to be found. We'll be the winners.
Our first task was called Dancing Lights. In this activity, we programmed several LEDs to light up one after another in a pattern, like they were dancing. It helped us learn how to control timing in sequences in Arduino using simple code. Even though it looks simple, it taught us how important wiring and proper coding are to make everything work smoothly. For our second task, we worked on traffic lights, but we decided to modify it to make it more realistic. We added a button for pedestrian that when pressed turns the traffic light red and activates a buzzer sound to signal that it's safe to cross. It felt great to see it work because it showed how a small idea can make a project more interactive and useful. This task helped us understand how sensors and outputs can work together and how coding can bring life system to life.
Overall, these challenges help us realize that robotics isn't just about connecting parts or writing codes. It's also about communication, problem solving, and supporting each other. Every mistake and struggle help us grow, not only as students but also a group. Looking back at our robotics performance task, we can honestly say it was a mix of challenges, learning, and fun. At first, everything felt complicated. The wiring, the coding, and even just figuring out how to make the components work together. But as we went through each activity, we slowly started to understand things better and became more confident with the Arduino. This experience really changed how we see robotics. Before, we thought it was just about connecting parts and typing codes. But now we see how it teaches patience, teamwork, and problem solving. We also learn how important communication is, especially when things don't go as planned. Every mistake turned into a lesson, and every small success motivated us to keep going. Looking forward, we hope to continue improving our skills in robotics and coding. This project inspired us to explore more about technology and how it can be applied to real-life situations. We're excited for what's ahead and confident that the lessons we learn here, both technical and personal, will guide us.
We will be there. Wherever we are, there's a fun to be found. We'll be the winners. Turn that corner, we jumped out the birds with a big, big smile. We'll be there.